Hey, good morning, folks. How you doing today? Happy Wednesday. Alrighty. Yeah, there we go. Yeah, SP Java. Yeah, thanks so much. I have things to say about Zoom. They don't do a very good job of following what the password guidelines are, and they just have a terrible system. So there's this really cool organization called NIST. Let me just Google them real quick. The National Institute of Standards and Technology. They have all sorts of really cool standards around like tons and tons and tons of things. And one of the things that they have is some password guidelines on like what makes good passwords here. So this particular NIST document here, I don't think so. I don't think those are generally recorded. Okay, yeah, I mean, we'll have to look and see what's going on if it's not working. So, yeah, always reach out to me too if you get stuck on something and we can take a look at it. But some guidelines here for passwords. Here's a nice little blog article that summarizes it because honestly, the NIST thing is a little bit nuts because they have like several different guidelines here. But some of their guidelines around passwords and things are good, and we should be using these sorts of things. And one of them is around password rotation. And it's saying we shouldn't be having to constantly change our passwords, which is obnoxious. And our Zoom account makes you change your password every, let's see, I think it's every 90 days, I want to say, because now my password has like 3 numbers at the end instead of 1 number at the end. And it's just bad practice to do that. But the folks over at Zoom want to do that anyway. And then the guidelines for lockout. Another thing they recommend is that you don't lock people out so fast. I think one of these ones here had, it would say like at least 10 attempts before you get locked out. Is it in here? Locking. Yeah, right in here. So at least 10 attempts before locking out their profile. And what our friends at Zoom did for us is, no, you get locked out much faster, and then you're locked out for half an hour. And you can't even go through like a reset process to get it turned back on. So that's awful. It's not good. So one of these days, maybe I'll go complain to Zoom about it, but I'm sure they're not going to listen and care anyway. So, there's that. So, let me catch up here on chat. Sorry, let's see. Yeah. Hey, good morning, David. And Lido Star, you'd give it 5 before you'd lock somebody out. So there used to be a thing, and this was years ago, but it was common that you could get locked out of like your Windows workstation here, and a good practice is when you go walk away, you lock it, which is good, so that no one else can get into your computer. But if you were feeling like messing with somebody, if they walked away from their workstation, you could go try and log in as them a bunch of times, just gibberish, not even trying to like actually log in as them, just locking them out on purpose, so that way when they came back from they were getting their water or whatever, they stepped away from the desk for, they wouldn't be able to get back into the computer. So there's, when it comes to security practices, there's all sorts of ways people can abuse sorts of things. And not even necessarily in a malicious way, that's more just being annoying. Can you clone a repository after you've already created a project? So, yeah, so if you make the project and it's not in the repository, is that what you're saying? You can then go create the clone of the repository so you get the folder. The easiest thing to do is probably just copy-paste. You can drag and drop files, but usually I would say just make a new project in there and then just copy-paste your code from one project to the other. Copying and pasting entire projects works, but it gets a little bit messy sometimes. So it's probably easiest. And what we're doing is just a single Java file anyway, so it's not so bad to do that sort of thing. And then if the folder names get wrong or something, it can be a little funny here with packages and all that good stuff. So I think generally it's easiest just make the brand new project in that repository after you clone it. Okay, so let's talk about the lab that was due today, Lab 2. Let's see, we didn't quite get as many people turning that in as I thought we would. Less than Lab 1. So we can go through it here. So let's do Lab 2. So the goal is to go over these after they're due. Again, to give you another chance to look at it here. So let's go through that process. Now, if I do it in the lab repository, though, it's private code. So I'd rather do it in my course repository. The code will be available for you guys to see it. Does that make sense? But we can go through the process too if you just want to see it again real quick. It'll be basically the same thing. I'll just pick a different folder. So, did I already make a lab 2? I think I might have already done that. So, click my link, get my repository, say with the code button, say open with GitHub Desktop. That's what happened. Yeah, I know what happened. Let's see. So, I have a lab 2. Okay, yep, history. So I did this lab 2 with, I just started it here. Okay, so yeah, so it's just started here. So it was empty, there's nothing inside of it. So we had gone through this last time. So you'd have to click the GitHub Classroom link first from this assignment. So every assignment will get its own link, and that link will generate the repository for you as part of that GitHub Classroom workflow. So each new assignment will have a new link to get a new repository folder, just to keep everything separate. So there'll be Lab 1 folder, a Lab 2 folder, a Lab 3 folder, a Lab on and on and on and on, a Project 1 folder, a Project 2 folder, and so on and so on. Just to keep them all separate that way. It'll make life a little bit easier and cleaner, I think, for us to look at these and review them all later. So, Benny, if you don't put them into the repository, then I probably won't be able to find the code. So the point of the repositories is it is a central location in the cloud where you have access and I have access, and then that's it. So that's the goal here. And then you don't have to do anything with code in D2L. Yep. All right, so we go find that lab 2. So once I've cloned that repository, right, again, if I'll say show and explorer here, this little link, or repository show and explorer, it's just going to open up my little file explorer right to that window. Yep, thanks, Benny. No problem. So this folder here, then, if I just kind of click in this white space, is in my C users, Eric C documents, GitHub, CIS 1500, Winter 2022, Lab 2, Eric Janeski. So that's the location of where this folder is. So then in NetBeans, when I go and start up a new project, file new project, I would go find that location to start my project. So Java Advanced, Java Application, and then I'm going to hit Browse here for my location because I want this to not go where it is right now. We'd say, hey, I want to go Browse, and then you're going to pick that GitHub repository folder. So you'd find Winter 2022 Lab 2. Now, I already have one there. Actually, I really want it in my Monday, Wednesday folder here because I want it to go in the public repository that I'm showing you folks. So that's what I'm going to pick. You guys would pick the Lab 2 folder. Right, and then here we'll give it the project name. I'll call this one Lab 2. And we'll go from there. Does that make sense for the step? So if you, in a different folder, just go make a new project and copy the code over into it. And it should work out pretty well. Right, coding's, I think something must be wrong with my settings here, because I haven't changed anything, and my OBS is getting all upset here with the encoding. Wondering what I did wrong. All right, so again, I'm taking out these comments here. I don't need these comments showing up, no big deal. And then we can start our lab 2 right inside of this set of curly braces inside of main. Let me see. The bit rate is fine. Oh, it's the encoder is the problem. Okay, I have to change that next time because that got screwed up, I think. All right, so inside of here then, we're going to look at, well, what do we need to do? We need to ask them for their name, and we're going to use it in all the prompts below. Ask them how many hours they worked, including partial hours, so we know that it needs to be a double. Ask them how much they get paid, again, including partial, so a double here, and then calculate their gross pay. Then we'll calculate an estimated net pay by, say, hey, maybe about 10% for taxes, and then display the net pay. Again, this was just a total estimate here. It doesn't, probably not accurate, but it's just, we'll just do some arithmetic. All right, so if we're going to be using and asking them questions and getting some keyboard input, we need to use this scanner class. All right, so scanner is part of the Java library. So you can't change the repository the project's in. When you make a project, you go File, New Project, you pick the location. So this is what tells where that's going to be. So you need to find that repository folder when you make it here. That's probably the easiest way. You can move them around, like entire folders around, but it's probably easiest to go this route because it'll be a little cleaner. So you just pick the project location for where you're putting it. All right, so if we want to use this scanner class out of the library, we need to give it a name. So this is our variable name. Again, the book says SC. I don't like SC. I like keyboard here because we're getting some keyboard input. Equals new scanner. Yeah, we can always check after, David. No problem. System.in. So use the new keyword, capital S scanner again, and then in parentheses, it's capital S system.in, telling Java, hey, I want to use the standard system input, which is typing in the console. Okay, and then it's still going to light up red and be upset with you. And if you click the little light bulb over here, it's going to give you a couple of hints. Most of these ones are bad. You don't want most of them, but the one at the top, add the import, is the good one. It'll type this line for you here. You could also go type this by hand saying, hey Java, I want the thing that's in your utility library, the thing called scanner. I want to use that in my code here. So remember, the Java library comes with all sorts of classes, all sorts of really cool tools that are already done, so we don't have to reinvent the wheel. Right? So we want to specifically use the scanner class out of the Java utility library. That's what we want to do. Okay? Now I'm going to be good to go. I can use this later on. So now we can ask questions with an output, and we can get their input with the keyboard next line. So we'll say, hey, enter your name. Right there. What's your name? Right? And then if we want to get their input, we need a place to store it. So we need a variable, and it's going to be a type of string here because I just want their text. The text. I just want the name. It's not numeric here. It's just whatever they type in. Here and it's their name. So we're going to call this one name equals keyboard.next line. We'll say, okay, anything they type in, we're going to assign to this variable called name. Now I can use this name anywhere else I want. Oh yeah, Benny, it is very case sensitive for sure. Yeah, so capital S, definitely case sensitive. Java gets real confused if you mess up the casing. Like with the system stuff as well, it gets really confused. And then you get these messages, cannot find symbol. And the hints for those, not what you want. Those are not the helpful ones. So not always really good hints here. But yeah, if you get stuck on something, reach out, shoot me a message. It's usually a pretty quick, I just have to look at it and I can figure it out in a minute or so what's missing. So sometimes the error messages are funky. Like if you're missing a semicolon, and the whole line is red, usually it tells you, hey, a semicolon's expected. That one's fine. But like, if you missed a parenthesis, it says can't find symbol next line. And you're like, what does that mean? I don't know what a next line is. So the hint is not good there. Or if you're missing like half a parenthesis, it says illegal start of expression. Like, what do you mean start of expression? So sometimes they're a little funny here. Like if you don't start a quote here, it gives you all sorts of weird things. One of those little hints there, it's a little small to see, sorry, it says unclosed string literal. That's the good hint. That you have a string in your code that wasn't closed. So we started a string here and never closed it. So they always need to come in pairs. So the errors take a while to get used to and figuring out what it actually means, but it'll get you pointed pretty much to the line you need to look at and see what's going wrong with it. And so we got their name, and then we're going to use their name in all their prompts. We'll say name, right, plus, right, to do that string concatenation. I want to take the name string, and I want to take my string and just stick them together here when I do the output. So name, how many hours did you work? Right, and then this is a numeric value, not a string type. So we can't have a string variable here. We need a numeric, and if it's going to have a decimal place, because you can work half of an hour or a quarter of an hour, right, it should be a double, because the doubles are the easy ones for us to use, numbers with decimal places. So this will be hours worked is going to equal, now I can't just do keyboard.nextLine. Java's going to yell at me again. Next line, please. Next line, there we go. Because it says incompatible types. String cannot be converted to double. Right? Because what you're going to get here with next line is always a string, and a string is not a numeric double, so we need to convert it. So the way we can convert things, we say capital D double dot parse double. We say, hey Java, can you turn this string into a double, please? And inside the set of parentheses, we can give it the keyboard next line. So this will do the conversion for us, convert whatever they've typed in into a double, assuming it works. It'll crash otherwise, and that's okay. We'll feel bad about it, but we don't know how to make it not crash yet. And we'll do the same thing for how much do they get paid. We'll say name plus how much do you get paid per hour. And then we'll have a double here again. So this will be our, I don't know, hourly pay rate is double.parse double. And really just copy paste this here too. It's probably easier than typing it all again. And we'll do that conversion. Now there are ways to use this keyboard class, the scanner class, to just get doubles directly. I don't recommend you use them because it messes it up for the next time you need to get keyboard input. So I will always recommend just next line everything and then do your conversions. It sounds like it's a little more work, but I promise it'll make life easier for you in the long run. Okay? So once we have those, now we can calculate their gross pay. So I'm going to use another variable. We don't have to, but I think this one makes sense here because we need to calculate it twice. Once to figure out what the gross pay is, and once to take gross pay and turn it into net pay. Right, so if you're going to do something twice, we might as well save the variable. A good general rule of thumb is if your code does the same thing twice, you should feel bad about yourself. And I mean that kind of jokingly. Like if you have the same code twice, there's probably a way to simplify it. Is all I mean. So let's say double the gross pay is going to be equal to the hours worked, or sure, hourly pay rate times the hours worked. And again, if you're not getting those type aheads, right, like as I type HO, and it starts showing me the variable names that fit HOR here, you got to change your settings. So when my hands are on the keyboard, I don't often move it over to the mouse. So I'm not going to go and click on these. You can click these if you want here, but more often than what I'm going to do is I'm going to use my arrow keys, up, down, up, down, up, down. And then once it's highlighting the one I want, I hit tab and it finishes typing it for me. So it'll be pay rate times my hours worked, semicolon. So it looks like I'm typing super fast, but I promise you I'm not typing more than a couple letters. Right? A couple letters here, a couple letters there, letting it complete itself. So if you're not getting those suggestions, go to Tools and go to Options. Go to the Editor tab here. Go to the Code Completion tab, pick Java in the Language dropdown, and make sure boxes 2 and 3 are checked here. Auto pop-up and subword completion. Those are your favorite ones here. Okay, that'll make sure that it's going to suggest your variable names for you. And then it's great because our variable names can be nicely long and descriptive. They can tell you exactly what it is. So using like H here and P here would be awful. Java wouldn't care, but it makes it really hard for people to read your code if your variable names are ugly. Okay, so we'll calculate their gross pay. And sure, we can tell them. Let's do net pay next. Actually, let's calculate them both. It doesn't matter which order we do it here, but net pay then is going to be gross pay times 0.9. Right? Take 90% of gross pay, because we were assuming you paid 10% in taxes, or 10% was withheld, or whatever, however that has to work, right? And then we can tell them. So your gross pay is, and then I'm going to add a $sign just because it's pretty here. We'll put in gross pay, and then we'll say, sorry, well, that was not what I wanted. That one there. We'll say your estimated net pay is plus net pay. What do you think? So we ask them their name, we use the name. Oh, we should use the names in the prompts here too, right? Name plus, probably a comma there, right? Probably commas. Right? I think that's probably proper. So name plus, okay, there. Now we're using their name in all the prompts. We ask for the name, we store their name. We ask for their hours, we store their hours. We ask for their pay rate, we store their pay rate. We calculate the gross pay, calculate the net pay, we spit them both out. Let's give that a run. See if this one works for us. And I have to go refill my coffee cup. I'm so sad it's empty already. I love this cup though. I got this one at Disney and it is huge. Like it's a fist-size mug compared to like those usual tiny coffee mugs. It's amazing. All right, so what's your name? Eric. And how many hours did you work? Let's say 20, and let's say you paid per hour 20. Gross pay is 20 times 20 is 400. 90% of that's 360. Looks like Java can do the math. That makes sense? So then I'm going to come back to GitHub. Again, I didn't do it in the Lab 2 repository because that one's private. So ours is actually in the class repository, my Monday, Wednesday public class repository. So you can go see all this code later if you're curious. A bunch of NetBeans files. Those are all great. And I see my Java file. Fantastic. It looks good. It's got all the things here. So I can put a message. Say Lab 2 done. Say commit and push. This will synchronize it with the cloud, and that'll be available online for you folks. Again, if you're doing the lab repository for it, you could go to the repository view on GitHub or click this view on GitHub button. And then you're going to go find your pull requests. For my public repository, I don't have the pull requests, but you go to the pull request tab. No, someone, okay, this was not, okay, that's fine. I think someone was doing some funny stuff, but that's fine. So you'd find feedback here, and you can go from it there. An equation to find the net for any taxes. Sounds like it'd be fine, Benny. I can take a look. I mean, all I really wanted to see was like you could do some more arithmetic. So if yours does arithmetic, that's fantastic. I'm cool with that for the lab. No big deal. Yeah, so lab 3 should be the same idea here. Let's go back to D2L. Come into lab 3, and there should be that lab 3 link at the top, the classroom link at the top. So go edit. Did we not talk about the project? So that was the GitHub Classroom link here. We'll ask if you want to accept the Lab 3 assignment. You can accept it, and then it will make the repository. You can go through that process of doing the clone. We'll make a folder on your computer in your GitHub directory called Lab 3, your username. You'll start your project in there. Did I not see project? We talked about project 1, right? We talked about project 1. Okay, it's right here. Okay, it's a duplicate of this one. I can just delete this one here. That's what was working. Okay, I was really confused for a minute there. Sorry. Let me just get rid of all of these here because you can delete all those. And they came over with the copy because it sets up everything nicely. All right, yeah, there's. Oh, it's in no category. We need a category for those is why. One of these days, folks, we'll figure this out. Okay, good. I was real worried. Because that'll help with the schedule. Yep, and so there should be, Mr. Tim figured out his Zoom thing eventually after they let him log back in, which is bad security practice. It's been locking people out for 30 minutes after less than 10 attempts. So on group tutor session today, 12 to 1. So the info's here in D2L. That's not my Zoom session, so it's just for you folks. So I'm going to leave it in D2L for all those links, because everything here I'm pushing out to YouTube, because text submission, there we go. And then let's make a new category here for projects. Projects. Awesome. Yeah, so we'll probably go till early 11ish some or so, and then we'll talk about the next labs. You'll have some time to work on the lab. So if you're interested in and have time to make that session, you can get a break. It's not going to go from this class right into that one. Hopefully you can get a little chance to stretch, that sort of thing. So the Tuesday evenings or the Wednesday afternoons, try and hopefully one of those two works for your schedule. And if they don't, you can definitely look at the individual tutoring sessions as well. We've got those as options too. So Mr. Tim takes attendance for the SI sessions for the bonus points. If you see an individual tutor, just make sure they send me a note that you showed up, and then I can get you in for those bonus points for the quizzes. So we should have, did I turn on the Chapter 2 quiz? Yep, the Chapter 2 quiz is coming up, due next week, right, because we finished Chapter 2. We'll talk about Chapter 3 today and next Monday. Again, it's a little weird. We start Wednesday and end Monday, but it should be fine, and then we'll do the Chapter 3 quiz from there. Yeah, we got 19 people doing quizzes. That's much better than people doing labs. Nope, so just type it into the box. So for the self-assessment for the project, when you go to submit it, just say, hey, for item 1, I got 2 points. For item 2, I got 2 points. Item 3, 2 points. That way. Don't you need to give me a document or anything. Yeah, just type it in. Yeah, so that's just your last check to make sure that you actually looked at the rubric, because the rubric is how I'm going to score you. So you can go through the Academic Support Center's website. I've got a link here in the syllabus because I don't actually remember what it is. Let's see if I can find it here. And then you go, you schedule through the Academic Support Center. Right here, so this tutoring link. Zoom back out a little bit. So for the tutor schedules, we're through the Orchard Ridge campus. We're the campus that has the software engineering program, so generally we have the CIS tutors who do programming classes. Some of the other campuses occasionally have CIS tutors as well, but start with Orchard Ridge is probably your best bet. So we have Miss Rika. Oh, Tim was on the list. Is he not on the list now? Yeah, he's not on the list. So Miss Rika does individual tutoring Wednesdays and Thursdays. You can book virtual appointments or even on campus, looks like on Thursdays. And she tutors for $1,500. She's been a long-time tutor for our department. She's amazing. Yeah, I don't know what happened. Okay, I'm not sure. You can ask him at the session what happened to the schedule. I like how the document says fall 2019, but it's winter 2022 here. Someone is not changing the right information in these documents. But that's where that is here, and you can contact them through that link there. All right. So I think we're good. Are we good to move on to Chapter 3 now? We start with a new project. Job with Ant, job application. It's in our class repository, so this is good here, because this is where I want all my examples to go. Talk about Chapter 3. All right, and I'm going to get confused because I have my other Chapter 3 project open here, so we close these ones down. Close and close. All right. There we go. Nope. Oh, I closed the wrong one. All right, my bad. Let me open my recent projects. This is chapter. Okay, this is the Monday Chapter 3. There we go. Here's the empty one. Sorry about that. It's fun having two different 1500s. So are we in this one here then? Is that the one we're in? So if you're ever not sure, if you just hover over the name of your project, it'll show you in kind of small letters where the path is. So this is the Monday, Wednesday one. This first one here is the Tuesday one. So I want the Monday, Wednesday one here. There we go. Well, happy Wednesday. And then we're going to use some keyboard input. So I'm going to make that scanner class right now. So scanner, I'm going to call it keyboard equals a new scanner, given capital S system in. And now I'll be able to go and get some input from the user. Oh, Java doesn't know what it is. Let's NetBeans write that import line for us. Import java.util.scanner, and we're off to the races. Okay, so we talked a little bit before about different types here, and we're going to look specifically at the primitive types in Chapter 3. So Chapter 2 had a lot of information. It kind of took you through a lot of things pretty quick. So we're going to go a little deeper here on these primitive types, and then a couple other interesting things at the end. We'll see how far we get. So of the different ways of storing values, right? We looked at integers here, where our regular numbers here. And these can be up to about 2 billion or so. Right? They do have a max here, but about 2 billion. So for most of our day-to-day numbers, these work pretty well. If you need more than 2 billion, right, we have bigger integers are called longs here. So these are really large numbers. These are whole numbers, right? So we should say really large whole numbers. And a long, the maximum of a long here, and don't think I have this memorized, I'm copying out of the book here right now, is 9 something, 223 something else, 372 something else, 36 billion, 854 million, 775,807. And now Java doesn't know what this is because it's a long, so you have to put an L to tell it that it's a long. A lowercase l at the end to tell Java it's a long. Okay, so this is not a 1, that's an L there, which is super confusing. But the good thing is, with your numbers, you can include underscores. Underscores get ignored, so because they get ignored, though, you can do dumb things with them, like put underscores anywhere you want, because Java's going to ignore them. What we should do with them is we should use them for digit groupings, because you can't have commas, because that would make too much sense. Not allowed to have commas in numbers, but you can have underscores. So now I can see this is millions, this is billions, this is trillions, this is quadrillions, 9 centillion here. Capital L, okay, yeah, okay. I've only ever seen it with capital, makes more sense. I like that. Where's an L? An L? A-L? Is it an L or A-L? I hate English. There we go. Yeah, I like the capital L is a little cleaner there. Thanks, Benny. Appreciate that. So regular sized ints take up 4 bytes of memory. And we looked at bits last time. I'm not going to do it again. It's interesting. Just keep that in your back pocket. If you want something smaller than an int, you have an option to use a short. So short is a smaller number. So shorts go up to about 32,000 or so. 32,767 if you actually cared, which nobody does. And if you want to get even smaller than that, you can have a single byte value. Is really small numbers. Bytes are negative 128 to positive 127. Sure, negative 128 to positive 127. Why not? We can put all these notes in here. This, that's just fine. We'll just copy. 768 to positive 32,767. This is our 2 billion or so to 147,483,648 to 2,147,483,647. Sure. Longs, that's the max. Basically that negative plus 1 for lots of fun reasons. All right, so those are our numbers, types, primitive data types. Notice they're all lowercase, and they all show up in that nice reserved word color. In my dark mode, it shows up orange. I forget exactly what it is in regular mode. I don't use non-dark mode anymore, and I forgot. Those are all reserved types. These are primitive types where Java just knows how to store these things. remember the way that we store our values, there are 8 bits in a byte. But one of those bits needs to be saved for positive or negative. And there is no negative 0, right? There's only positive 0. So the negative bit being on is going to be negative 1, right? So then you can get 1 higher with the negatives than you can with the positives. So if the positive or negative bit is off, it's a positive number, and then the remaining 7 bits we can get up to 127. But if the negative bit is on, then we still have another 127 we can add to it, plus the negative 1, right? Because negative 0 and 0 are the same thing, so negative 0 doesn't make sense. Yeah, if you're getting all the way to the edge here, you've probably done a wrong thing anyway, because sure, just use the next bigger type if you need to get any more specific. So there's a fun story. Did I tell you folks about NASDAQ and Berkshire Hathaway when we talked about ints? That one was kind of interesting. I don't remember who I told it to now. That ring any bells? The NASDAQ and Berkshire Hathaway? Okay, it's a good story. We'll tell it. If you want me to skip it, I'll skip it. But the way that the NASDAQ was storing stock prices, they used 4-byte integers. Oh, yes, I did tell you? Okay, sorry. Yes, okay. It's a good story. So, cool. So we've looked at some of those. So other types then, right, deal with decimal places. Right, so generally we're going to use doubles here. Doubles are the numbers with decimal places. Number with decimal places, like 7.7, sure. You do have the option here of using a smaller number with a decimal place. It's about 15 seconds behind? Oh, I'm sorry. Oh, man. It's not usually that laggy with Twitch. I don't know if my encoding's behind or something. I got to change some settings, I think. All right, so doubles are great. These ones take up 8 bytes here. You've got smaller numbers with decimal places are floats. This is smaller numbers with decimals. And again, I don't like floats purely for this reason, that when you try and tell it you want this number, you get an error, possible lossy conversion from double to float. To tell Java it's a float, you have to put an F here. And F to tell Java you want a float. A float. Right? But the reason why floats are nice is they take up 4 bytes of memory. They're half the space. But again, you get less decimal places. So doubles, you can get 16 significant digits. Floats, you get 7 significant digits. Okay, is it a little laggy? I'm sorry. I think some of the settings got messed up. But if I try and change it now, it's probably going to screw it up even more. Maybe a break. I'll just stop the stream and then I'll come back in a couple minutes. So my encoding got changed, and I think that's probably why it's not doing the hardware encoding, which is super weird. We'll give that a shot, and maybe a break time. Okay. However, if it's too terrible now, we can bail out and take break early, and I can change that and see if it works any better. Up to you. I'm happy to do it either way. All right. So we've got floats and doubles. And again, the reason why I don't care about using floats is the things that we're doing at our scale don't matter. Because remember, our computer has so much memory, right? A kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. And a gigabyte is 1,000,000,000 bytes. So our computers generally have billions of bytes of memory that if you can save 4 bytes, no one really cares. Now again, if we're doing something at like millions of numbers that we're storing, and you can save 4 million bytes, sure, that's like a significant difference. But nothing we're going to do in this class is going to come to any sort of scale where it matters if we use 8 bytes or 4 bytes. And then it's just easier for us to use doubles because we don't have to remember to put an F everywhere. So, all about making life easy. And then some other types here. Remember, we had chars. Char was a single character with single quotes or apostrophes here. Right? not double quotes. So it's not a string. A string is a bunch of characters. A char, the primitive type, is just a single character. And the funny thing about chars is, this is another, we'll do uppercase A. How about that? Uppercase A. These are all Unicode values. So these are actually numeric values. So I can say, hey, uppercase A equals 65. And if you go Google the Unicode table, you can go see the value, numeric value of every letter that's being stored. So I can scroll down and see, hey, the capital A, and if I hover over it, it tells you it is a decimal 65. Or I think I have to click it. There you go. Decimal 65. Right? E was a decimal 69. So if I wanted to write my name out letter by letter by letter, I could. Right? So I could have a char for, here's my first letter, is 69, and a char for second letter is, let's see, what is a lowercase r? A lowercase r is 114. You say 114. And then a char third letter is an I. It's going to be 105. It's a good thing I have a short name here. 105. And then a char fourth letter is going to be C. That is 99. 99. And then remember, there's a difference between print and print line. I think we talked about that briefly. So print line will go down the next line. Print will stay where it was for the next time you print. So I can do a couple prints here if I wanted to. And I can print my first letter. I can print my second letter. I can print my third letter. And I can print my fourth letter. Right? And if we give that a run, we should get out Eric. Look at that. Happy Wednesday, Eric. Now, what's going to be funny, though, like usually when we were doing prints, we could just say, hey, let's do the first, like some string plus the second, some string plus the third, plus the fourth. Right, all on one line. We get a number back out, though. Right, so dealing with characters, these are numeric values. So a character plus a character is not letter plus letter. You don't concatenate the letter with the other letter like you would a string. You get number plus a number. Java says, oh, you want addition? I'll do addition for you. And then we have no idea what we got. Right? So this is no good. This will add the numeric values. So that's why I had individual prints here. Right? Print, 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 print line to do one letter at a time. That's really obnoxious. If we wanted to, we could probably concatenate them together here. It did go down a line here with the last one. So that's why Eric goes down a line. So C was printed, print line goes down here, and then print line 387 going down a line, and then the cursor was here, and then we get this build successful line. So it should have started a new line at the end here, and then at the end of this one. Because it was print line for the fourth, and print line when I tried all of them here. Yep. So if we wanted to, we could make it work here. Oh, I don't want the comments, though. By adding in more strings in between them. If we had a string in between each one, then it won't say, oh, hey, you want arithmetic. It'll say, oh, hey, you want characters. Right? Strings between, it should work. Right? Because then it says, oh, character plus a string, concatenate. Character plus a string, concatenate. Character plus a string, concatenate. It won't do the arithmetic, but just character plus character is going to give you arithmetic. Right, so I don't know, whichever one you think is easier. And again, we're not often going to do these one letter at a time. But then the next fun thing you can do is you can do like a simple cipher. So it's not encryption here, but like simple, is it a Caesar cipher, I want to say? Yeah, simple Caesar cipher. That's like a tongue twister. I should not be doing these. And the idea with a Caesar cipher is that you just replace a letter with another letter a fixed number of positions down the alphabet. right? So we'll say, okay, so maybe A turns into B, B turns into C. That one's pretty easy here, but again, that's kind of the idea here, that one letter turns into the next letter. So we could do that same sort of thing here with my letters. So I could take my first letter and I could say, hey, I want to change the value of it. I want it to be equal to the first letter plus 1. Now, this one actually doesn't work well because character types only store 2 bytes. When I say, here's a character plus an integer, it's telling me, hey, possible lossy conversion from int to char. It says you just added an integer. It might not fit into a character. So we've got some ways here. We can tell Java, hey, do the arithmetic, please. And then, P.S., by the way, please, I really want this as a character. So we'll say, hey, please treat this as a character. I know it might have bad things happening, but it's fine. Or we could take my second letter, right, and we looked at this combined assignment operator. You can add 1 to it. So plus equals 1, we'll say, hey, add 1 and then assign it back here. Remember, you got to be careful with these. That is not the same as second letter equals plus 1, right? This is fine, but what you're doing is you're assigning it the value of positive 1. This one says add 1 and then assign it. So this one is real bad, so you got to be careful with those. Okay? Or we could say third letter, there's a new operator. If you want to just add 1, it's just so common to just add 1, you can just say plus plus. This is the post-increment operator. It will increment after it's used. We're not using it right now. That'll make more sense next chapter. Don't worry too much about it. Or you can also say plus plus, the fourth letter, is the pre-increment operator. Depends on what you're doing. Probably not all that often. There's a lot of fun things you can do with individual characters. One character at a time. We'll play with them a lot. I'm not sure how practical it is, breaking things out one character at a time. But there's a lot of things that we might do, or once we get to talking more about strings, you can get one character at a time out of strings and do a lot of things with them. So there's fun stuff you can do with it. Probably not super practical. I don't know, but a lot of things you might have to take one character at a time. So it could be useful for sure. So then if I went and I've added 1 now to all of my characters, and I print this out again, here we're going to get the simple Caesar cipher for Eric's name. Now I am fizzed, right? So I've now put my name through a simple little cipher and translated some of the letters. Okay. Now the tricky part is like if I had a Z in my name, Z plus 1 is not a letter. Z plus 1 is not A. So there's some other interesting arithmetic stuff we can do to look at that later. Maybe we'll have some fun with that for our lab. So we've got assignments. We've got naming conventions. Again, this camel casing, always lowercase. Next words start with uppercase to make things easy to see. And then if you're a way you can help yourself, right? If you are dealing with something that's a constant value and it should not change, we can use a special keyword in Java. We can say final int, and then final values, we follow a different naming convention. So they're all uppercase. We say like speed of light here. And now, if I tell you speed of light, I think most people in physics know this is probably meters per second, or maybe kilometers per second. Most people aren't going to tell you in miles per second. But if there's a unit, we're going to include that here. So we'll say in meters per second. And I don't actually remember what that is. So speed of light in meters per second. Meters per second is, let's see, what do we get here? 299,792,458 meters per second. And again, you can't have commas, so I'm going to replace those with underscores. That was 299, right? Yeah, 299,792,458 million meters per second is the speed of light. And what this does here now is I can use this name in any calculation where I'm doing something with the speed of light instead of having to retype this number every time. So that's good because I don't have to type this number, because the more often you type a number, the more likely you are to typo it, right? It's really easy to like swap 2 digits around. If I had like 54 instead of 45, and then I went to do all sorts of calculations and tried to get to the moon, bad things would probably happen. Although I don't actually know if we use the speed of light to get to it. Do we use that? We probably do. Physics is not my strong suit, so. And the other thing it lets you do with this final keyword, if you try and change it, let's say, oh, hey, let's change it to, let's just say it's close enough to 300 million. It gives you a big fat error and says, cannot assign a value to final variable. Once a variable's been assigned, so final values, variables can only be assigned once. Right? It will just error out at you. So you can't actually go and change it. So it helps make sure that you don't change it by accident, which is really nice because that would mess things up. So these are for constants. Anything that's a constant. A couple different operators here is pretty fun. So I think, did we talk about doing integer division? So if we said 10 divided by 3 is equal to what? And we actually printed out 10 divided by 3. So let's do that as a print here. And then this is a print line. Sure, we can just concatenate it in. Why not? 10 divided by 3. We'll do it all in one line. Do you remember what we get when we do 10 divided by 3 in Java land? This is called integer division in Java. So what we get here, sorry, you said there's lag, so you're probably not able to answer the question without me waiting a weird amount of time. You get an integer result. That means any decimal remainder is just truncated. So int divided by int will give an int. So you lose the decimal. The decimal remainder is gone. So what you can do then is, you think back to 3rd grade math class where you start looking at what is a remainder. We can calculate the remainder. So I can say 10 divided by 3 equals 10 divided by 3 plus remainder of, now to get the remainder in Java, that's 10, you have a modulus operator. Is modulus, gives the remainder, the division. So 10 modulus 3 is the remainder of 10 divided by 3. So modulus is a really helpful operator here. It's really cool. So 10 divided by 3 is 3 remainder 1. Now we're doing 3rd grade long division. Actually, we're making the computer do it. My 10-year-old was super mad that she's not allowed to use a calculator for her math class because her older siblings are starting to use calculators now for their math class. So my 14-year-old and oh my goodness. I know how old my daughter is. My 12-year-old. Right? No, 11. She's 11. She's turning 12 in March. So the 11-year-old and the 14-year-old are using calculators, or starting to for some of their math problems for the 11-year-old, and the 14-year-old's pretty much always using the calculator now. And she's so mad. She's like, I want to use a calculator for my math. I'm like, you're not ready. It doesn't work like that. All right, so we can do that. So if you want to get a double result here, so 10.0 divided by 3 will equal 10.0 divided by 3. So if either operand, right, either number that's being operated on is a double, the result is a double. Okay, so this one now, when we run it, we should get 10.333 or 3333335. That's a really weird rounding. Turns out Java is actually really bad at math, and like these billionths and trillionths will randomly be off. So don't trust it to do very precise math with these primitive types. There's lots of reasons behind it that are not super interesting. Combined assignment, yeah, we talked about order of precedence. We did parentheses, definitely. Converting between types, cool. Yeah, we did converting. All right, so the math library. There's all sorts of cool things built into the math library here in Java. Excuse me. So we can have 10 divided by 3. This will be, how about rounded is, or equals. So math dot, so capital M math, will give you all sorts of math functions. If you want the tangent of something, if you want the square root of something, the sine of something, if you want to round a value, if you want to take a number to a power, if you want to multiply exact, the max of two different numbers, the log of something, you can do floor division, you can do floor modulus, I don't even know what FMA is, actually, cosine, arcsine, arctangent, yeah, all sorts of crazy math words here. Absolute value is pretty common. But if we want to round, we can say math.round. Math.round, 10.0 divided by 3. So rounding now is going to round to the nearest whole number, so that should round down to 3. Right? If you want to round up, there's a function called math.ceil here. Round it up. Now, math.ceil has this crazy definition. So as you start typing these, like, it'll give you the definition of what it does. It says returns the smallest, closest to negative infinity double value that's greater than or equal to the argument and is equal to a mathematical integer. Oh, that's a mouthful. It just rounds up to the nearest whole number. If you're already at a whole number, it stays the same. So, two different ways to check this here. So 10 divided by 3 rounded up is different than 10.0 divided by 3 because 10 divided by 3 is already an integer value, right, with integer division. So we get 3. There's no rounding at 3 because it's already an integer number. With 3.33333, that will round up to 4. So when you're looking at planning your party and making sure we buy enough ingredients, right, we want to use math.ceil to do that rounding up. All right, so I've been talking for a little while. I know it's got a little laggy here. So let me actually stop the stream. I'm going to see if I can change that setting real quick, and then I'll come back. And we'll take our break. We'll come back, say, about 11:10, maybe 11:11 or so, and we can go from there, okay? All right, let me give this a stop. I'm going to change the setting and then restart it here, and hopefully that'll take care of some of that for us, okay? And hopefully it'll be a little bit nicer. So I'll see you back in just a little bit. Whether or not it works, maybe we'll be back with lag, maybe without lag. We'll see how well that goes, okay? So I'll be back in just a minute.